Hello guys, welcome back to my channel, Men's on African Motives. In this platform we shall be focusing on coordinate geometry for mathematics N3. So we have a question from one of the question papers that I'm having here. So we shall focus on this question. So if you're new to my channel, you can consider subscribing so that you won't miss any of the classes that we shall be having from Men's on African Motives. So we have the diagram there, which is a quadrilateral. A, B, C, D is shown in figure 1. The vertices of the quadrilateral we are given A, B, C, D are shown, and these are as follows. So these are the points on the quadrilateral, and we are also given that beta, the angle there on the quadrilateral. And yeah, I think that's the information that we have. And the first question is to calculate the gradient of line CD, the gradient of the line CD. Okay, so take note that gradient, guys. We have this formula for the gradient, which is the change in y over the change in x. That's y2 minus y1 over x2 minus x1. So we have CD. So this is your point 1, this is your point 2. Okay, from C to D. So on D, that is your point 2. So you have x and you have y there. So it's going to be 8 minus 12. So this x on D, this y on D minus this y on D. So it's 8 minus 12. So you've got 8 minus 12 like this. You move on to the x2. The second point is D. So you need the x on D, which is 2, minus the x on C, which is minus 8. So it's 2 minus 8 like this. Or you can just list your points. This is the point C, minus 8 minus 12, so that you don't get any confusion. This is your point D, which is 2, 8. So you name your points. This is your x1, this is your y1, this is your x2, this is your y2, like this. So now you can substitute into the formula, which is this formula for the gradient. Okay, so at this stage you can actually use your calculator to simplify this fraction. So we have something like, you just put a fraction there. That's 8 minus, then you use this minus here in bracket. So you open bracket and use this minus for the sign. So take note, it's minus 12 over 2 minus 8. So it's minus 12 like this over 2. You subtract, then you open bracket and use this minus. So it's minus 8, or you can just use a plus, because minus and minus gives us a plus. So the gradient is going to be 2. That is the value that you're obtaining here, which is 2. Okay, so that is the gradient of the line CD. So we just leave this. Maybe we might use it in another question. Okay, let's see what we are having on the other part. So on the other part, you're asked to determine, you're now determining the size of beta. So this is the angle beta, the angle of inclination between line CD and the x-axis. So this is the angle of inclination. As we can see, yes, it's an angle of inclination, this beta here. So we know that to calculate the angle of inclination, we are going to use the formula that tan beta is equal to m, which is the gradient of the line that is with x-axis, which is line CD, like this. So that means our tan beta is equivalent to the gradient that we obtained for CD. Remember, the gradient of CD was 2. So to obtain beta, this one, you just use your calculator. So on your calculator, you must have this tan to the exponent of -1. So it's arctan. So to obtain this, you must use this shift pattern, shift tan 2, and make sure your calculator is in radians. Okay, so you're going to obtain 63,435, yeah, to 3 decimal places, something like that. So this is the angle beta, which is 435, just maybe to 3 decimal places, or you can even leave to 2 decimal places, fine. So this is 63,435 degrees. Okay, maybe we might need to use this beta, we don't know, so let's just leave it like that. Then the length of the diagonals on 4.3, we are asked to calculate the length of the diagonal line of quadrilateral ABCD we need the length but of the diagonal line. Which diagonal line? Joining points B and D. Joining points B and D, which is this diagonal line. Leave your answer in the simplest said form. Leave your answer in the simplest said form. Okay, so this is length. Length is actually distance. Okay, so you're going to use the distance formula. So from our distance formula, we understand that the length, so we need the length of what? Of BD, which is the distance of the line BD. So the formula is x2 minus x1 squared plus y2 minus y1 squared. So this is the formula for what? For length. So for distance, so length is same as distance. So we have B and D. Take note the diagonal BD. So you can actually list this so that you don't get confusion. Your B is -16, -1. That's your B, and your D, that's 2, 8. This is your point D. So this is your x1, this is your y1, this is your x2, this is your y2. Take note, guys. Okay, so you can actually substitute. This is BD, which is equivalent to the square root of x2 minus x1. That's our x2, which is 2, minus our x1 is -16, like this. So it can be something like this. Then you square this bracket, plus this is your y2, which is 8, minus your y1, which is -1, like this. Then you actually square everything. So this is a presentation that you have to show this whenever you are given a formula and you are substituting on the formula. You don't simplify whilst you are substituting. You substitute as it is. Then you can do whatever that you want to do, but here you are supposed to substitute as it is, like this, because you are substituting on the formula. So you are supposed to show directly as it is on the formula. Okay, so now using our calculator, we can just have this square root. So it's the square root of, you open the bracket as it is, you simplify this part as it is. Okay, so it's 2 minus, you subtract, then the minus that you're going to use, you put a bracket like this. So is it going to give us, or you just write it as it is, this minus here, just put it as it is, you put it minus 16, there is no effect, then you square that. Okay, plus, you open bracket, it's 8. So take note, this is 8, then you use this minus here to subtract this one. So it's 8 minus, like this. Then you use this minus for sign, for a sign, this minus in bracket. As you can see, it's already in bracket. That is why we are not putting the bracket here. So it's minus because it's already indicating that it's in a bracket. Okay, so it's -1. So it's -1, you square that. So you are going to obtain 9 square root of 5. That is the simplest said. Remember, you are asked to leave your answer in the simplest said. So we obtained 9 square root of 5 units. So this is length or distance. So distance can be just measured in units, like that. You can just write your distance in units, like that. Okay, then let's see another question that we are given. On 4.4, we are asked to determine the equation. We are still following this question. Okay, so determine the equation of the line passing through the point D. Okay, so it has to pass through this point D. So you're given a point there that is perpendicular to BD. Okay, that is perpendicular to BD, which means there is a line which was drawn like this, and it's perpendicular to BD, which means it is making an angle of 90 degrees with this part here. Because take note, the equation of the line passing through point D. So this line is the one that we have, this one which passes through point D, which is perpendicular to BD, like that. Okay, so what is the concept? Okay, so after finding this equation, you're asked to leave that answer that you're going to have in the gradient intercept form. Which one is the gradient intercept form? Okay, so this is our 4.4. When you're working with the gradient intercept form, this is y is equal to mx. mx plus c. So there's nothing special about this. We need to find the equation first. So let's take the properties that we are given. Take note, guys. The line that we are talking about is perpendicular to BD. This line that is passing through, let's just say this is our line L. It's perpendicular to line BD. Not parallel, but perpendicular. Sorry, not parallel. This is perpendicular like this. So if these two lines are actually perpendicular, what is the relationship between this line, which is perpendicular to the line BD? It's about their gradients. The gradient of the line that we want to calculate and the gradient of BD should give us a -1. The product for perpendicular lines, the product of the gradients should give you a must give you a -1. So you cross-check, did we calculate the gradient of BD before? No, we didn't. We just calculated the gradient of what? Of CD, not BD. We calculated this CD, but BD we never. So we have to calculate the gradient of what? Of BD. Okay, so M BD, which is the gradient of BD. Still we have the same formula, guys, for gradient. That's y2 minus y1 over x2 minus x1. So you can just substitute on the formula. But remember, I once wrote these points for BD here. I once wrote the points down for B and D. So we listed x1, y1, so we just substitute here. So on y2, this is our y2, which is 8, so it's 8. So take note, I said on the formula you substitute as it is, so it's 8 minus y1. Your y1 is -1, so it's going to be -1 like this over x2. You substitute your x2, which is in this case is 2, and your x1 is -16. So it's 2 minus -16. On the formula, you substitute as it is. You don't use 8 plus 1 over 2 plus 16. No, guys. This is a substitution of the formula, okay? So take note about that one. So now just put this on the fraction from your calculator. This is going to be 8 minus, remember what I said, there's a minus this one to subtract, and the minus of the sign in bracket this one, so it's -1. It's already in the bracket like that. Okay, we have 2, you subtract, then you use this minus in bracket to indicate a number in bracket, okay, like this. So you're going to obtain 1 over 2. This is the gradient of BD, which is 1 over 2. Then what about the line that we are talking about here, which is going to pass through the point D and it is perpendicular? Then we are going to use the concept that this gradient of this line multiplied by the gradient of BD, which is 1 over 2, should give us a -1. So therefore, what is the gradient of this line that we want? So we are going to divide by half there. So it's -1 divided by the answer that we obtained, which is -2. Okay, so take note, in this case this is multiplying, so you're going to divide by this so that you remain with the gradient of the line, which is -2. So since we are given to leave our answer in this gradient intercept form, I can actually substitute on that formula direct, because I have the gradient of the line now. So I can just substitute the gradient y is equal to mx plus c, because I want the equation now. So the gradient of the line, because they are perpendicular, is now, it gave me -2. So take note, guys, about this type of equation. You calculate the gradient of BD not because you want to use it, but you want to obtain another gradient from this one. So this is the one that you're going to use, which is -2. So y is equal to -2x, because m represents the gradient, plus c. So we have to find the value of c, but how can we find the value of c? Remember that this line, we are given that it passes through the point D, or it has to, okay, let me just take this again. The equation of the line passing through point D, so it must pass through the point D. So we are given a point there. There's a point D that we are given, which is 2, 8. So we have the gradient and we have the point D, which is 2, 8. So that means I can actually calculate the equation. I'm just going to substitute this point in place of x. Yes, there's that this equation that you use to find the equation. Yes, you can use this, or you can just use this because you are given already the format to use. So this is x and this is your y. So in place of x, you're going to substitute 2. In place of y, you're going to substitute 8. So in place of y, let's substitute 8. In place of x, let's substitute 2. So take note, this is negative 2. So it's negative 2 by 2 plus c. So which means I'm supposed to find the value of c. So take this to the other side. It's going to add. So it's going to be 8 plus minus 2 by 2, which is 4. So it's 8 plus 4, which is 12 in this case. Okay. So our c in this case is 12. So we have the value of c. Therefore, the equation is going to be y is equal to minus 2x, which is already there, plus c, which is plus 12. So you're supposed to obtain the same answer even if you use this condition of y minus y1, which is 8, which is equal to m, which is the gradient, minus 2 into x minus x1, which is 2. You're supposed to obtain the same answer. Okay, let's expand. Y minus 8 is equal to minus 2 times x. That's minus 2x, minus 2 times minus 2, which is plus 4. So to leave our answer in this format, we have to transpose this negative 8 to this side, which is y is equal to negative 2x. Negative 8 to this side is going to add. So it's 4 plus 4, 4 plus 8, sorry, which is 12. So y is equal to minus 3x plus 12, like that. So as you can see, we could have determined this in another way or another format. Okay. So that was worth 5 marks for that. As you can see, it's 5 marks. Yeah, it's worth it. His calculations, they are worth his marks. Okay, 4.5. Determine. We are still back to the same thing of determining, but this time we need the coordinate, so the equation of the line passing through C. That is this time parallel to BD, leaving the answer in the same format, the gradient intercept. Take note, this time they are parallel to BD and it passes through the point C. Okay. So let's see what we have in this case. This is 4.5. This line is going to pass through the point C here, and it's parallel to BD. So it means something like this, which is parallel, something like passing. So this point C is minus 8, minus 12. So I'm just going to take the point C, minus 8, minus 12. Okay, we know that if two lines are parallel, then the gradient of the two lines will be equal. If you are given line 1 being parallel to line 2, their gradients are equal. So it means here, this line that is going to pass through C is parallel. Take note, is parallel to BD. And we have the gradient of BD from the previous question that we did here. This was the gradient of line BD, which was 1 over 2. So we are going to use this gradient as it is. Okay, so we are going to use this gradient as it is because they are equal. So our gradient is 1 over 2. So now let's determine the equation of the line. So remember, we are supposed to leave our answer in the form of y is equal to mx plus c. So you can substitute here, or you can use that formula that we used. Still, we are going to obtain the same answer. So we have y minus y1. This is x1 and y1, this point. So your y1 is negative 12, which is equivalent to m, which is the gradient. Use this as it is because these ones, they are parallel. Okay, x minus your x1, which is negative 8, like this. So let's simplify and see what you're going to have. Negative and negative, that's a positive. So it's y plus 12, which is equivalent to negative and negative, that's a plus here. So you have half of x. Then you have half of 8, which is going to give you a 4 from your calculator. Half times 8, that is 4. So leaving our answer in the form of y is equal to mx plus c, is going to be y is equal to, this is our mx, which is half x. Then 12 to this side is going to subtract, so it's going to be minus 12. So it's 4 minus 12, which is negative 8 from your calculator, if I'm not mistaken there. But that is the condition. So y is equal to half x minus 8 for the line that is passing through the point C and parallel to the line BD. Was it BD or? Yes, it's BD and parallel to BD. We are going to use the gradient of the line BD to be equal to the gradient of the line that we are talking about. So by doing so, you can actually determine the equation of the line. Okay, so that's how you determine this. On 4.6, you're now asked to determine again the coordinates of the point of intersection of the following two lines. Take note, the coordinates of the point of intersection. Okay, I talked about this from the previous part, that at the point of intersection, the two functions are equal. The two functions are equal at the point of intersection. So which functions are we talking about, or which graphs are we talking about? There is a line through point D that is parallel to the x-axis. Okay, let me start by explaining this part of being parallel to the x-axis. Whenever you are given a line that is parallel, this is your x-axis, guys. Okay, where we know that in the x-axis the equation of this line is y is equal to 0. Okay, so any line that is parallel to the x-axis is supposed to be like this. This is parallel, which means they are maintaining same distance or equal distance throughout. That is to be parallel to the x-axis. So this line is going to pass through a certain point, maybe it's 7, and the value is going to be the same. So this line is going to be y is equal to 7. So which means any line that is parallel to the x-axis is going to be written in the form of y is equal to a, where this a is the value of y at the, where this a is the value of y at that point, or at the given point, which means this point here, what is the value of y is going to be, as long a line is parallel to the x-axis, the equation is going to be y is equal to a, where this a is the value of y at that point. When a line is parallel to the y-axis, when it is parallel, it's now like this, that is to be parallel to the y-axis, the equation is going to be x is equal to a when it is parallel to the y-axis, where this a is the value of x at that point where this line is passing through. So this one is parallel to the x-axis. This one is parallel to the x-axis. So, and it passes through the point D. So we said when it is parallel to the x-axis, is y is equal to a, where a is the value of y at that point. So what is the value of y at point D? Because it has to pass through point D, and our point D here, the value of y at this point is 8, because this line is going to be like this. It's going to pass like this. That is to be parallel. This is your x-axis, so they are parallel. So you have y is equal to 0, and this one is y is equal to the value of y at this point, which is 8, not the value of x, but the value of y. So which means we have two lines now that we are given. The one that is parallel to the x-axis, which is equation, we said it's y is equal to 8. That is the equation of this line. It's y is equal to 8. And we are given that it is going to intersect with this line of y is equal to minus 2x plus 2. They are going to intersect with y is equal to minus 2x plus 2. Okay, so we now have two equations, and I say that the question is saying calculate the coordinates of the point of intersection. Take note, the coordinates of the point of intersection. And I told you that at the point of intersection, take note there, at the point of intersection, these two functions are equal. So it means y is equal to 8 is the same as y is equal to minus x plus 2. So if they are equal, what am I going to do? I'm going to solve the equation, which means 8 is equal to this part of x, which is minus 2x plus 2. Because this y and this y, they are equal. So it means these two also, they are equal. So which means I can solve for x. 2 to this side is going to subtract, so 8 minus 2, that is 6, which is equal to minus 2x. You divide by minus 2 by minus 2, so your x is going to be negative 3. So that is the value of x at this point. So already we have the value of y, because if I substitute this minus 3 here, I'm going to obtain the same value of 8, because they are equal. So the same value of 8, the same value of x. So if this is the value of x, therefore the point, remember the point is supposed to be xy like this. So therefore our point is going to be x, which is minus 3, and the value of y that we already have, which is 8. This is going to be the coordinate of the point of intersection. That is the point of intersection, this one. Point of intersection. So that's what you actually need to understand in this case. At the point of intersection, the two functions or the two graphs, they are equal. So if the two graphs are equal, or if the two functions are equal, what does that part actually mean? It means that you can solve the given equations by equating the equations to each other. Therefore, you can solve. Okay, so that's actually the typical questions that we can have for mathematics N3 on coordinate geometry. So guys, not to miss these classes, make sure that you subscribe to my channel Maison African Motives, as we shall be working on revisions for mathematics N3 on all the areas that we need in our syllabus. So if there is any part that still have a challenge, let me know on the comment section. So don't forget guys, thumbs ups, and don't forget to share our videos to our friends and colleagues so that they also can benefit from this information. Please guys, do help us by sharing our videos to your friends and colleagues outside there. Thank you. Till we meet again.